So thank you very much for that introduction. Yeah, I was given that name by my colleagues many years ago. I cannot let it go when I hear somebody needing help, somebody struggling with something. I can just not let it go without stepping in and trying to help out. So that's basically it. I work at Trusec, which is initially a Nordic or Scandinavian Swedish company. We are about 320 cybersecurity consultants today. We have offices in the Northern Europe. We just started an office here in Munich a few months ago. So we are trying to grow here as well. So what I do on daily basis, I help out internally within our organization, but also towards our customers to fix problems. Discussing both architectural, strategic issues, but also down on the keyboard doing incident response engagements, chasing threat actors, and so on. It's a lot of fun. My calendar looks empty, but somebody's calling and you just run. So we're gonna focus on the passwordless topic for the next 39 minutes. So what is passwordless? A lot of you have already some relationship to what passwordless is. If I would go back in time, my first encounter with passwordless, if I would call it that, was back in 96, 97. Microsoft released the first certificate services in the Windows platform. If anybody remember that, Windows NT Option Pack, right? That's where we got the IS server. A lot of offensive people loves IS because you can hack it many ways. And we actually got certificate management in Windows, and that progressed into the next releases of the Windows platform. That was my first encounter with certificate and key-based authentication. So we could get rid of that frickin' password. So certificate-based authentication in my world, passwordless, is actually going all the way back to the basics. It's key-based authentication, with or without certificates. So all of the flavors that we call passwordless authentication we have today are based on key-based authentication. When you get that notification on your mobile phone, when your authenticator app says, hey, are you signing in? When you do your consent and you do number matching, whatever you do in the foreground, what happens in the background is a key-based authentication. So whomever want to attack these kind of systems need to do is that actually to get a hold of how the key-based authentication is working. Where do I possibly get those keys? How do I possibly breach that system that generates the keys? Once again, with or without certificates. So classically speaking, in enterprise environments, we have been using certificate-based authentication, both on premises and in cloud, which is an awesome passwordless methodology. We have some specific flavors that we call them the smart card logon. It's still the same thing, just different names. And we have the key-based authentication, which is the Windows Hello for Business. Now, the Windows Hello for Business is just an extension of the passwordless or the key-based authentication that was reinvented by Microsoft in Azure. And then nowadays we have things called security keys, right? FIDO2 implementations and all of that. Once again, the basic component in the background is the key-based authentication. So all you need to do if you want to attack that kind of system, just understand where the keys are generated, how they are provisioned, who's keeping an eye on the validity time of those keys, etc. Can I possibly inject something somewhere? Can I fool somebody to give me a key or register a key on behalf of me as an attacker or user, etc. So I just need to put my head around on these kind of things. So I will be focusing on the enterprise side of this rather than the cloud side. I said, if we get this going, then we can get all the other pieces going as well. So the last rolling 12 months, I've been involved in approximately 180 incident response engagements. Yeah, that's an appointment, I don't think. You see, somebody just called it. So 180 incident response engagements where around 50% were full ransomware deployment. If I would recall how threat actor, what they used for authentication, I would say maybe 1 or 2 cases threat actor used something that reminds us of passwordless. All of the other cases were just plain password reuse. Password hashes, etc., guessing passwords, and so on. I can just recall 1 or 2 cases from the last rolling 12-month period. And in both of these cases, we're not talking about the threat actor that is just a classic ransomware threat actor. We're talking about threat actors that are state-financed threat actors. Because the classic ransomware threat actors, they don't care about being silent or being careful or being undetected. They are extremely loudly operationals. They just hit and grab. They basically do whatever they can do the shortest period of time and so on. Yes, they do spend some time on the keyboard to try to figure out, where are the crown jewels of this organization? How can we do to exfiltrate and so on? But they're really not relying on any fancy type of authentication methods nowadays. Why is that? Because we, the ones on the other side, the ones on the keyboard as admins, we are not using passwordless. Most of the organizations are still relying on good, classic, old password-based authentication. So if we would step up the game, that would probably change some of that. So the existence of PKI-based or key-based authentication in an organization that gives a threat actor or an offensive guy a very valuable opportunity, right? So if you just look at any enterprise environment today, just pick anything, you would most probably find either one or multiple PKI structures supporting that environment. You can most probably do very advanced key-based authentication scenarios in those environments, although they are not used actively. And what if somebody actually starts using that? Would we be able to track it? Would we be able to see it? Would we be able to react on it? So we'll just give you an idea about how easy things are in that regards, and what can we do about it. Let's see. We've been doing red teaming for quite a long time, like almost, or penetration testing, then it became red teaming later on, and then purple teaming, etc. So I personally have been using, I said my first encounter was in the mid-90s, and then been personally using certificate-based authentication, both for good and offensive purposes. Like the last 1.5, almost 2 decades. When we do red teaming, we oftentimes end up in extracting certificates for an object in that environment, and then using that to authenticate to wireless or VPN or something like that, which is awesome. Because you don't need that password. Let the user change that password. How many times they would love to change that password? I'm not relying on that password anymore. I just can go ahead and use that certificate that is valid for 1 or 2 years. The most awesome case we had in one of our red team scenarios is that we actually extracted a server certificate. We stumbled upon that server through an exposed SharePoint site, so we ran code on that server. So we had the server certificate in hand, and we could actually authenticate to the wireless network with that one. So we had that kind of persistency in that red team. Isn't it awesome that servers can also authenticate to wireless networks? Yeah, because they are just the main computers, right? So with the introduction of some offensive toolkits, like Certify or Certify, different flavors of the same thing, this thing has become a lot more easier. So nowadays, you can just run these fire and forget tools. You don't need necessarily to understand what's even going on in the background. You just need, if I run this tool with these parameters, this thing will happen. So you don't need to be a PKI expert. You don't need to study how that thing worked or something like that. So let's go to some of the really, really good old basics that we have here. So how about just doing a very classic one? I'm logged on as a user, or have actually accomplish to get the credentials for a user. In this case, the user is called user with that password, abc.123, which is, by the way, a complex password. Right? So it's as easy as you just run this tool, or you can actually run any of the built-in tools in Windows as well to do the same thing I just did now with this tool. So I requested and I got a certificate issued to me or to that user at sciencecdemo.com. And that certificate is now exported in a PFX file. So I can just take it and install it wherever suits me, and then connect to the VPN or connect to the wireless or do what's next in my agenda. So have we seen this in action? Yes, we have seen this very simple one in action. We've seen the threat actor remaining persistent access through VPN to an environment more than a year by doing this. They were just running VPN connectivity using certificate that we're extracting this way. So that will give you a certificate worth like using for 1 year or something like that. So why not? Seize the opportunity and just go ahead and use it. And by the way, all these fancy things that tells you, yeah, you know, we flag the certificate as non-exportable. It's all in, when I generate the key, I can redesign that. I can decide to export the key. I can decide to do other things with those keys. Yes, Windows as such, my enterprise configured device will try to be compliant with the rules, but I can override that as an attacker. Generate my keys, push the request, and then get the certificate and work with it offline or out of band. So all we need to do is just grab that certificate, and the next time I would need to probably authenticate using that one, and I can just use that certificate to perform an authentication. If I now do KList, here we go, my Kerberos ticket for that user with that certificate I just got. Yes, I could have used the password I know about, but now this thing is not relying on the password anymore. So I can, if I trick a user to run this command or something like that, then I have now disconnected from that dependency. And I totally independent in my access, regardless how this password changes or not. So this is the out-of-the-box experience if somebody would just like to grab a certificate. And it's not harder than this. You don't need to be an admin. You just need to be a regular user in the environment. So what are the issues that have arisen? In an enterprise environment, when we talk about enterprise-grade PKIs, we talk about certificate templates. Specifically speaking, Windows environment, PKI as such is really governed by the certificate templates. So certificate templates are objects in Active Directory, a recipe that tells the user, the consumer of certificates, and also the CA service how to behave. All of the aspects are described in the template. So life is easy. So what happened here, if you go read the certified pre-owned white paper that was released back in a few years ago, you will see that there are yet a lot of opportunities to abuse this. There are some very few ones related to the service itself, but then the majority of the opportunities are related to the way we configure those templates and the way we configure our systems to behave. So a lot of the EST1 up to 10 are basically on the template side of the things. There are a few ones on the certificate services side. They are not really vulnerabilities, more like a creative way of doing things, rather said. So some of these configurations we tend to put together allows for impersonation. So I, as a regular user, can all of a sudden request a certificate in somebody else's name and become that user because of a misconfiguration. So how would that look like? What's the most frequent case we see out there? So let's start first with the enumeration step. What does it take to enumerate? Once again, just using the Certify. I mean, if one tool can do it all for me, why not using that one? Still authenticating with that user. And then let's see, what kind of templates it identifies as. Hey, give me vulnerable templates. That vulnerable definition relies on one thing, which is a property that is set. It says enrollee can supply subject information. So whomever is pushing the request can actually decide what should go in the ready-made certificate. Isn't that awesome? So just, hey, can you please give me a certificate and I want to be administrator? That's handy, right? So I got two templates in this case. There is a custom user, no SID, and there is a custom user. Both of them allows enrollee to supply subject information. Cool. So the next step would be for me is that to actually try to abuse this. Why not abuse it such way that, hey, we should try. So I'm just using that same user, now requesting a certificate in the name of another user called CA admin. Because I'm trusted as a user to supply subject name information. Now the CA looks at the recipe and says, yes, you are allowed to do that, and then here is the certificate for you. Cool. So what would be the next step? Let's try to authenticate with that certificate and see what's going on here. Wrong thing selected. There we go. Now, I'm not successfully authenticating here. It's giving me an error message. The error message says object SID mismatch between certificate and user CA admin. So what is this? What's going on? It worked for the regular user, right? But it didn't really work when I supplied a custom subject name or something like that. This is because Microsoft have done some changes in the system. Since the release of that white paper, a few vulnerabilities were identified and a few things were fixed and a few adjustments in the system were applied. So one of them is the last bullet that said strong mapping to address some of these issues. So yes, I am able to ask for and get a certificate in the name of another user, but the system is telling in the certificate that, because you're not requesting a certificate for yourself, I'm not including your security identifier in the certificate. So therefore, when you authenticate, the domain controller will see, you're trying to authenticate as somebody else than you because your security identifier doesn't match. No, you're not authenticating. That's a failed authentication, right? So is that really an issue? Let's have a look. So let's get the security identifier for that user called CA admin. That's the security identifier for that user. And if I get the security identifier for my own user I'm using right now, so there is a difference in one digit, right? So what if we do like this? Because I'm trusted to supply subject name information, I'm actually also trusted to supply that security identifier. That's part of the game. If you trust somebody to impersonate somebody else, you gotta trust them to do it all the way, right? So now I got a certificate that says with this security identifier, but I'm not that user, but I got it because the recipe says I'm allowed. By default, it's not matching, so I'm not getting it, but if I know what to inject in the request, yes, of course I can go ahead and use that one. And if I would try to do the authentication again, then everything is just fine and dandy again. But perfect matching between the SID and the certificate. And then I can go ahead and start or continue my abuse cases in this. So just a few words about this. What Microsoft did, they enforced or added a feature called strong certificate binding enforcement. This now was May 2022, right? This patch was introduced 2022. And then Microsoft added a hard limit and said, yeah, by October, November 2022, we will actually do full enforcement mode regardless what you think. They were quite aggressive in this question. They say, okay, this is abused in the wild. We know a lot of people, a lot of offensive, a lot of TAs are using this, so we're going to actually enforce it regardless what. Now, if we look today, what happened with that flipping to full enforcement mode, it's actually been prolonged to, guess what? 2025. Because probably a few rather large accounts been reaching out to Microsoft, say, this is no go. We will not be able to do it with that short notice, so give us some more years. We can still change this on our own. It's a registry key. By default, everybody is running in compatibility mode, which means if the SID matches or not matches, then the authentication will be successful. And I would love everybody to switch it to full enforcement mode. Then you would need to test your applications and your situation. But there is another loophole in this. This also applies to TLS and certificate-based authentication in TLS as a protocol. This is not just the Kerberos protocol that is affected. Which TLS? You know, when you run HTTPS, when you run LDAP-S, when you run anything that is with that tiny S, you know, TLS style, you are able to do mutual certificate-based authentication, which is, once again, key-based authentication with a certificate, right? So you can do the same strong mapping requirements on the TLS layer, the S-channel layer. And then there is a specific registry key for that as well. So we just need to go back to those CVs and read up on what keys we need to work with. So a lot of people misses out on that one and say, yeah, but if I do the strong mapping, am I all good? They forget about the S-channel and TLS because you're still vulnerable if you don't fix that one. What else can we do? I still need to have that template that allows some specific users in my organization to have the freedom to request certificate on behalf of other users, like for reasons. So is there a fix for that? Yes, there is a fix for that. So I can design a template and add a flag, the MSPKI enrollment flag, just add a specific value, the one that is shown here, which says, regardless what is supplied in the request, there will not be any SID extension in the ready-made certificate. So yes, you are a server admin, you would like to get web server certificates. I give you a template that allows you to do custom-made certificate, but you will not be able to get your domain admin certificate and the domain admin SID. And by the way, I'm requiring strong mapping, so I'm safe. So this gives us back the flexibility to be able to have those templates that gives that ability to act and react and perform on behalf of operations, but then we hold back with what kind of certificates are we actually giving you the ability to do with the disable flag. And just remember this one, this is more of a reminder. So even if Kerberos doesn't do that, LDAP will do that. So if I manage to impersonate the domain admin, I cannot do Kerberos style authentication, but wait a minute, domain admin connecting to the LDAP interface and Active Directory. That's still a domain admin, right? I don't need to do a Kerberos style authentication. I can still go there and change objects in Active Directory and become somebody, change membership in groups, create new users, etc. It's all about an LDAP operation. So we need to think a little bit beyond that point and say, no, you cannot do like a smart card logon. Yeah, but there are other interfaces that are not requiring a smart card logon. They don't require Kerberos style authentication. I can do certificate-based. Right? So what if somebody enables certificate-based authentication in as an Azure tenant that has binding to the this on-prem environment, and they are relying and trusting the on-prem PKI for doing MFA-style certificate-based authentication in Azure AD? Wouldn't that render the same problem? Because Azure AD doesn't do SID mapping. It's only on-prem domain controllers that does SID mapping. So this problem can transfer into the cloud as well, very, very easily, if we're not really careful about what we're doing. So what else is interesting here? You know, we mentioned Windows Hello for Business, right? So what is Windows Hello for Business, once again? It is key-based authentication without certificates. So you need to have your keys provisioned into the on-prem Active Directory and Azure AD, right? So your public key needs to be binded to your user entity, both in Azure AD and on-prem, for that to work in Windows Hello for Business model. And you don't have a certificate that needs to be issued by the local or a PKI entity or an authority, right? So this means I can just generate a key pair. So if you look at how Windows Hello for Business is actually running behind the scenes when you do provision your Windows Hello for Business on your laptop or other device, your system is actually generating a key pair for you. The public key is made known for Azure AD and for an on-prem AD by pushing it to a specific service. That service will make sure to put it on your user object, and then that is synchronized between the on-prem and the cloud, or just in cloud, or just on-prem. There is actually no requirement to use Windows Hello for Business, technically speaking, to have Azure AD. The demo environment I'm running right now have not ever seen any Azure AD tenant. I don't have any binding between this and Azure AD. So let us have a look at how that looks like. So basically, I'm still using the same tool once again. By the way, I'm the CA admin now, so we can probably do like this. So yes, we are domain admin. That admin is actually, otherwise SRV01 is a domain controller. You would not be able to list the file system on a domain controller if you're not domain admin. Just to have. So, oops. This is how easy you create your Windows Hello for Business credentials on an on-prem environment. You just need to have enough power to write to that property. So you generate a key pair, push the public key to that property of that user, and from now on there is a strong binding between that key pair and that user. So you can actually do smart card logon or key-based authentication, and that's another word for Windows Hello for Business on-prem. So if you guys want to deploy key-based authentication on-prem without any connection to Azure AD, yes, it is possible. This is how you do it. Maybe you would need to use some other tools than Certify, but right? It's not harder than that. So I do have a shadow user now, which is, if I use that one to authenticate, so see, in my command line, I'm just presenting a PFX file. I'm not doing anything. So now I have authenticated back again with the user. As a proof, I'm getting the user NTLM hashes and NT hashes. That's what kept presenting got hashes for. So I'm now, the most elegant thing with this flavor, there is no due date on the key pair. I can keep using it forever because there is no certificate that will expire. Would somebody be able to detect that somebody injected a key? Do we have that capability today in our monitoring and detecting systems? Is there anybody looking into that? Actually, kudos to Microsoft Defender for Endpoint and Defender for Identity, by the way, the combination of these two, because they just recently added a lot of controls and a lot of detections in regards to all of these vulnerabilities that we're discussing about right now. So a lot of them will be actually flagged when you do them, and you have Defender for Identity monitoring your systems, your on-prem Active Directory. You will actually get those flagged. It says, hey, be careful. Somebody is actually doing an out-of-band provisioning of keys on your users. Just so you know, this is not going the ways it should go. It's somebody just explicitly setting that property. And yes, it worked. Oops. So this is now, once again, the ticket of that user presented to me. We see it issued just 1323. So I got that going. And you just need to have a line of sight to the domain controller. So if I'm a threat actor, establish my access through like connecting to Wi-Fi using a certificate or VPN using a certificate, I just need to have continuous line of sight to a domain controller to get my Kerberos tickets. So every time they expire after the 10 hours, initial 10 hours, renewable for a week, that's another flavor of passwordless. But most of us will never consider Kerberos as a passwordless protocol, right? Because we are thinking that initially you would need a password to authenticate Kerberos. Or, no, PKInit, which is PKI-based Kerberos-style authentication, is making Kerberos totally passwordless. With or without the certificate, the flavor with the Windows Hello for Business, the one just shown here. So yes, a threat actor can actually persist in an environment for quite a long time, not even bothering about the user password. And the same thing is applicable if we happen to use key-based authentication in cloud. We will see the same thing, just binding this to in the cloud model. So let's take an example of Azure AD. In Azure AD, you as a user will provision your own MFA method, right? The majority of tenants will use that or will rely on that one. My first log on, and I will get prompted to, now you go through this process to register your MFA methods, right? Your authenticator app, your security keys, and so on. What if a threat actor is actually successful in tricking my user to authenticate him or her? Wouldn't that threat actor also be possibly successful with running the MFA setup wizard, right? If you, as a user, can go back to the MFA setup wizard and run it again and add another authentication method, a threat actor in your shoes will be able to do the same thing. We've seen this multiple times. Users got phished. There is an authenticated session, stealing the cookies, stealing the session itself, etc. And then immediately threat actors goes registering a new MFA device. They are not tampering with the ones already existing. They register a new MFA method. Boom. They just look at your policies and then configure another MFA method. We also seen they actually go and adjust your answers on those security questions for your password reset. So they have a way back in case somebody removes their MFA authentication method. So they can actually, we've seen them doing a password reset session to regain access and then re-add another MFA so they go passwordless again. They're not fooled. They're just thinking, how could I survive in a world that looks like that, right? The permissions on the MSDS key credential link attribute are pretty good initially. So you need to be like domain admin or something like that. But you also will need to delegate those to some other entities, especially if you have Windows Hello for Business running. There will be other accounts that will need permissions in this one. For instance, your Azure AD sync account will need to have permissions to work with these, right? How many would value the Azure AD sync account as a domain admin? You should, because that's your domain admin, because it's able to adjust that property for all of the users, including your domain admin. So if somebody can make the jump from, the cloud to on-prem and use this, they are domain admin. As far as you have the ability to provision Windows Hello for Business style keys, then cloud is your domain admin as well. So just remember that one. Actually, in the initial release of Windows Server 2016, Microsoft did they had a little bit too flexible permission set on that attribute. They fixed it later on. So, another special corner case, which is the enrollment agent setup. What is an enrollment agent? Enrollment agent is a special design, which is per PKI. I can give somebody or something, it's either a person or a function, I will give them a certificate that would entitle them to act on behalf of other users. So there is a method we call co-signing. You co-sign the request that is sent to the CA. Therefore, you act as an enrollment agent. That gives you a lot of powerfulness. So if I can get hold of an enrollment agent certificate, I will have a trustworthiness in the PKI system to be able to act as other users. That's an added level of trust, right? So be careful with those templates and those who, if you already have that, like your certificate lifecycle management system, if you happen to have that one, used to be an enrollment agent, because otherwise it will not be able to conduct those operations it's allowed to do. So somebody can actually use that to become something else. And then just a quick reminder, it's possible to restrict that. So it says the default setting, this is ADCS. Default setting is actually do not restrict enrollment agents. Everybody should go back home and then flip this to restrict enrollment agents, especially if you know you're using enrollment agents. So yes, that certificate lifecycle management system can become anybody, but within these restrictions. It can definitely not become a domain admin, because I can do that. Permission setting says allow and deny and so on. So, what we have been discussing here, I need to understand that all keys and certificates in my different systems are, in most of the cases, exportable. There's only one very specific case, which is if you manage to put the keys on specialized hardware. So what is specialized hardware? It's a smart card, it's a physical TPM or logical TPM, so it's a security enclave within your hardware setup, right? Either a smart card, the credit card size smart card chip, or a security enclave TPM style, or an HSM device, hardware security module. If you put the keys in specialized security container that doesn't allow the keys to be exported, that's the only situation when you can guarantee my keys will never leave my machines. In any of the other cases, regardless of any other settings you have in your systems, and it doesn't matter if we're talking about Windows Hello for Business Cloud only. No, I don't have on-prem Active Directory. I just only run with, So as soon as the keys are software-based, they will be exportable. So I should account for that. I should expect that. I should conduct the assume breach mentality if I have that thing. So keys will not be safe. And it doesn't matter if it's a user object or computer object. And I need to go back also and revise my configurations and so on. There is another very interesting attribute in Active Directory on each entity, which is the alternative security ID. That's a manual mapping that can be done. It can do a binding between a certificate or keys and any user object or user entity, computer entity in Active Directory. So you just need to show that if the certificate is trusted, then you'll be able to sign in. So I can actually take the same certificate and map it through the alternate security ID attribute to multiple users, and all of a sudden I have a one-to-many situation where I can use one certificate to sign in as multiple users. That's also something I need to keep an eye on. And then remember the shadow credentials and the enrollment agent restrictions. If you happen to have enrollment agent, obviously. And shadow credentials works since the introduction of Windows Server 2016. So if you have a minimum of one Windows Server 2016 as a domain controller, shadow credentials will work every time. It doesn't matter what's your operational level of your Active Directory and Forest is. Shadow credentials only requires the presence of one domain controller that is 2016 or above. And it will just work in the background. If you have an enterprise PKI that supports the domain controller to have its domain controller certificate. So please keep an eye on that and this. I will be around both for the remaining of today and the whole day tomorrow. And I'm also reachable through different medias, social medias, etc. So just give me a shout out. If you have any questions, we can discuss them. And thank you for listening.